Hi students, today we will implement half adder and full adder circuits. So just open your logic gate simulator and add a blank file. So from the video you have seen earlier, you know about the circuit diagram. Okay, we have used one XOR gate and one AND gate to implement half adder circuit. Half adder circuit, as you know, is a combinational logical circuit that add two bit data. Okay, two data bits, single bit data A and B, that is half adder. Only single bits can be added. Okay, so we need input, that is by toggle switch we can add. So these are two inputs, A and B. Just add label to it, that is A, and second one is B. And after that we need a XOR gate, and one AND gate. You can have the circuit diagram from Google, okay, or from your note, your digital electronics books. You can implement any circuit diagram here. So just put the label. XOR gate, as you know, is used for your output for some bit. It will contain some of the two bits, okay, A and B. So we can use output like red LED for output for some, and another LED. You can take green one or which you like. I have taken green lamp for carry bit. So just now we need to connect the circuit. So just and from here we will have our output sum bit, and okay, you can adjust it like this. You can adjust it like this, you can move it, and this one. Okay, your circuit is complete. So you can verify your truth table here. Okay, when both inputs are 0, sum bit is 0, carry bit is 0, and when I change one of the input, you can clearly see your sum bit is high and carry bit is low. And when both the inputs are high, sum bit is 0 and carry bit is 1. So our truth table is verified. Okay, you can just toggle the inputs and see sum bit is always high when one of the input is high and other is low. Okay, either your A is low or your B is low, but one of the input must be high. Only that there is a sum bit at the output, and carry only exists there if your both the inputs are high. Only then there will be carry. Okay, 1 1, as you know, it is 0 and there is a carry in the circuit. So this is your half adder circuit. So you can save it like half. Okay, so I have just given you idea about half adder implementation. Okay, you can write Boolean expression for this from your truth table. Okay, so we approach to find an expression through Boolean. Okay, so we will consider only ones at output. For that combination of input, we will use sum of product technique. Okay, we will only consider the combination of inputs when the output is high. So sum of product method we can use to find the Boolean expression. So you will learn it in your theory classes, how we can write the Boolean expression. There are two techniques, sum of product and product of sum. In product of sum, we consider 0 out bit. Okay, the only input combinations in input variables we consider for the 0 output in product of sum method. So once you go through your theoretical part, you will clearly understand how we can design our circuit from truth table, given truth table. Okay, your truth table is basically a problem solving technique. Okay, your input variables are just input from your sensors, 0 1 in the form of 0 1 digits, and depending upon the output, when the output would be 1 or 0, we can implement any of the approach in our Boolean expression, that is sum of product for one output and product of sum for 0 output. So generally we use sum of product method. So as you once go through your theoretical part about Boolean expression, so it will be very easy to you to write the expression in the form of your combination logical circuit. So this is the simplest logical circuit, half adder. Only two components are there. So just try to write down your Boolean expression from your truth table. After that, we can implement that expression into our logical circuit. Okay, so that is enough for today. You can practice your full adder circuit. Okay, you can implement in this, otherwise we will cover it in our next. Okay, so just practice your full adder circuit. You can get the circuit from your textbooks. So just try to implement that and try to solve the Boolean expression for that circuit. It's a vice versa approach. You can also write Boolean expression from the circuit, and you can also write the you can also implement the circuit from your Boolean expression. So just try to implement full adder, otherwise we will cover it in next lab. Thank you.